Okay, so do you guys make it through that last section? 4-4?
Yeah.
What was that? I've already forgotten.
The last question was the one where I had to guess, and I just spent like 20 minutes.
Oh, the bungee jump one? Yeah, feel free to come by if you want to talk about it. It's not on the test.
Yeah. It's not.
That ended any interest right there, didn't it?
It's not.
Right.
But wouldn't it be in calculus?
You'll never see it again. No, it might be in calculus. Yeah, sure. Come on by. I'll be glad to talk about it with you. All right. So G of F of negative. Let's do this one more time. Make sure this is making sense for you. So this is number 2, right? Question number 2 in 5.1. So remember what it means on a graph. When you put something inside that's X, the answer that comes outside is Y. That's the key to functions with graphs. That's the connection between graphs and functions. Whatever you plug into the parentheses is X. What comes out is Y. So toaster, whatever you put in is X. What comes out of the toaster is Y. Right? So on the graph, so Y values, X values. Okay. So we're talking, so what are we doing then? First off, F of negative 1. That's the start on the inside. F of negative 1. So if you put negative 1 into the F, which one's the F graph? This one. So put negative 1. So find the point. See those dots here? Find the dot that has an X value of negative 1. Well, it's this one, isn't it? Wait, it's not working for me. There we go. That's this one, which is negative 1, 0, huh? That's his X value, and his Y value is 0. So that means the answer is 0. For the first one, that's what comes out. Now remember, this is a function in a function. So this is like me putting my toaster in my refrigerator, right? You put the bread in, you push down the lever, you shut the door. Both machines operate on the bread. First, the toaster toasts the bread, and it pops up from the toaster, comes out of the first function, out of the toaster, now it's toast. And then the refrigerator begins to work on it, cooling it down, so that eventually it's chilled toast, right? So that's how F and G work. You start with the inner function. You put a -1 into the F machine. It pops out of the toaster a 0. That's the answer coming out of the F machine, out of the F graph. Put in. So these XY points are inputs outputs, aren't they? On a graph. So the points are XY input output. You with me on that? Any dot on a graph is XY input output. Put in a -1, get out of 0. Pick any dot you want. Like, what's this one right here? This looks like over 2, down 3. Put in a 2, you get out a -3 from the toaster, etc. Any dot on any graph, XY is input output. They just made it that way, math science world, by common agreement. They just said, hey, when we go to functions from graphs, we'll make the X be the input and the Y be the output. They could have changed it. That's just what they decided. So, does that make sense? Input, output, XY, XY. So, I put in -1, out pops 0, because that's the point on the F graph. Now that 0 goes into the outer machine, like my toast. Now the outer refrigerator begins to operate on what came out of the first function. So G of 0. So that means we're at this point doing G of 0. Right? That's what's popped out of the F machine. So now G of 0, that's the input to the G function. So find the X value on the G function. That's right here. This is over 0 up 3. That's the input to the G function. What comes out? 3. That's the final answer. So first pops a 0 out of the inner machine. Put that 0 into the outer machine. Out pops a 3. Good? Questions I can answer? Want to try the next one? So we did that one. What did we do? 1 and 2? A and B, I mean? Let's try B. Maybe we didn't do B. I don't remember. Try G of F a 0. Same graph. Same two graphs. G of F is 0. So now we're putting 0 into the F machine. Start on the inside. 0 into the F machine. Something pops out, put that in the G machine. It's all about the dots on the graph. Input, output, X, Y. So put 0. So what's F? What comes out from you put a 0? So find on the F graph the one that has an X. Remember, inputs are always X's. X value 0. That'd be this point right here, huh? This is over 0, down 1, X, Y on the F graph. So put in a 0, out comes a -1, huh? Input, output. Out comes -1. So now, -1 goes into the G machine. You go into the outer machine last, like the refrigerator last. So now put -1 in the G machine. So look at the G graph. Which dot has an X value input of -1? This one. This dot right here. This is -1 up, back 1 up 1, isn't it? That's the input output for the G. So put in -1, out pops +1. Put in -1, out pops +1 from the G machine. Final answer, +1. So we put 0 into F, out pop -1, put -1 into G, out pop +1.
Easy peasy.
Good? Is that making sense how to trace that on through? Like I said, one of these two, I don't remember which one, either the graph or the table we did last time, is on the exam we take in, what, a couple weeks?
No, in 1 week and 6 days.
All right, not quite 2 weeks. First two. The rest of the way, the rest of this section is going to be functions, like this. You know, the rest of the way it's going to be no more pictures, no more tables. That was just 1 and 2, but those are important. Like I said, one of those two is on the actual exam. So now let's do f of g of 4. What have we learned that means? F of g of 4. Remember, functions go right to left. 4 goes into the G machine. Whatever pops out of the G machine goes into the F machine. What pops out of that's our final answer. With me on the process? So let's put 4 into the G machine. Here's the G machine. Put a 4 in the X slot. That's G of 4, isn't it? That's 4 plugged into the G machine. We good so far? What comes out? What's that? 9 times 16 minus 1, which is some big number, 143. All right? What's that? Oh, is it +1? Yeah, +1. So that'd be 145 then, maybe. Am I right? I think that's right. 90, 54, 104, 145, yeah. So far, we're not done yet. That's just what pops out of the G. So we put a 4 into the G machine, out popped a 145, which we're now putting into the outer machine, right? Like toast popped out of the toaster. Now the refrigerator is going to do its thing on the toast. Now the 145 into the outer F machine. You okay? You good? Now put one here. What's the F machine do? 7 times anything you put in it. So it's just some big number. I got a calculator. 7 times 145. 1015? That's the answer to part A. So you're running the 4 through both machines, aren't you? It's a composition. Like compose, like music, they put all the different instruments together and they make a composition, right? Putting them together. All right, let's try B. See if this is making sense for you. How about G of F of 2? Now they're switching the order, aren't they? First you're going to go into the F machine, then whatever comes out into the G machine. It's always right to left. That's always how we do functions. Right to left. Nothing has changed. So put 2 into the F machine now. See what you get out. Put that into the G machine. So F of 2, 7 times 2, 14. Pops out of the F machine. Right? 14 pops out. So put that 14 into the G machine. Is this good? Am I losing you? It's all good. 14 into the G machine. Here's the G machine. It's 9 times whatever you plug in squared plus 1. So I don't know what that is.
1765.
Thank you. I thought that's what it was. I just hate to show off. Sorry. Yeah. Good? We good there? All is well, so I'll skip C and D. Well, yeah, it's the same thing. You just run it through them twice. Do you want to do those?
Nah, we're good. Next we'll play.
Just run them through them twice. Same thing, right? Maybe I'll do C real quick. So you just run 1 into the F machine. So that'd be 7 times 1 would be 7. So out pops a 7. Then run it through the F machine again, which is 7 times anything you give it, 49 in the end. Is that okay? Not too quick? So I took the 1, I put it in the F machine. What does the F machine do? 7 times anything you give it. So 7 times 1 became 7. So 7 popped out of the F machine first, went into the F machine again, and then 7 times 7, 49. Good? All right. So Let me show you. All right, so they want the domain. And they want the domain of the composite function. That's the putting together of the two functions. Okay, so how do you do that? Well, notice when they just write f of g, and there's no like number like 2 or whatever afterwards, then that just means stick all of g into f. All of g into f. There's no particular number. They want me just to stick all of g. Remember, it's always right to left. Always. Always right to left. That's how we always do functions, right? F of 2, for example, means 2 into f, doesn't it? It's always right to left. Nothing new there. So when they write this, they want me to stick g into f. Why all of g? Because there's no number. They're not saying 4, 2 or 4, 3 or, you know, this particular number, that particular. They're saying all of g into f. So I'm going to take my toaster and stick it in my refrigerator. They want the whole creation. They're not running any particular bread through it or number through it. Just, hey, what is this new creation where you put one thing inside the other? So you take all of g and you put it in the x slots of f. Does that make sense? Because that's what it means when you put anything in f. You put it in his x slots. Those are his input slots, aren't they? They're like the holes in the toaster. Right? So this will become, f of g will become something on the top over something minus 5 layers. Kind of overlapping with the words. Let me give a little more room here. So f of g is something over something minus 5. And what is that something? It is going to be g, which is minus 6 over x minus 6 over x. Does that make sense? Yeah. Now we got to clean that up, but that's the first step. I just stuck g into f, right? I took g and put it into the two x slots of f. Okay, now, actually, they're not even asking me to clean it up. All they want is the domain. Okay, so they just want the domain. Now, what have we learned about domain? Domain is about what you can't put in, right? Like you shouldn't put tinfoil in the microwave. Shouldn't put knives in the toaster, right? Things you shouldn't do. So, okay, so what does that mean? What should we not? What x cannot be what? Like, I mean, what can x not be? Well, anything that makes a denominator 0. Remember, that's the big problem? No denom can equal 0. You can never let any denominator. Okay, well, do you see that we have two different, well, we have 3 altogether denominators, 2 being different. What am I talking about? Let's circle all the denominators. Every denominator, I've got to set, well, yeah, let me just say it that way. How about every denominator not equal to 0? It's another way to say the same thing, right? No denominators can equal 0, or every denominator cannot be 0. So, okay, so take every denominator you see. Well, here's the denominator, okay? So that one cannot be 0. That's what they put there. And here's a denominator, but that's the same thing. That's what I meant by 2 are the same. What's the other denominator?
The big one on the
that whole thing. That's all a denominator. That's what I was missing the first time. So that whole thing cannot be 0. That's the second and different denominator equation. Does that make sense? That whole denominator cannot be 0. Okay, well, how do I solve that?
Common denominator of x.
You could do that, yeah. Or you could just move the 5 over and cross multiply.
Yeah.
Whatever. Either way. So I'll just move this over. Becomes a positive 5. It's not equals. Positive 5 when you jump it over. And then you can put the 5 over 1 and diagonal, cross multiply. Seen that before? Those two. So minus 6 times 1, bring it here. Minus 6 times 1 is x times 5. So that's minus 6 is 5x. Last step. Am I going too quick?
No.
Everybody seeing that? So I'm trying to solve for x. I move the 5 over, become positive 5. Put it over 1 so it looks like a fraction, so I can go diagonal. It's called cross multiply. Get minus 6 times 1, x times 5, and then finish solving for x. So x cannot equal. So that's the other one. Cannot be negative 6/5. Those are the two denominator restrictions. Can't be those two numbers because those will make denominator 0 if you let it be negative 6/5 or 0. You could have solved this equation by, if you're wondering, can't we just multiply by x? Yeah, you totally could have. You could have just multiplied through by x, cancels here, would have got minus 6 minus 5x is 0, because 0 times x is just 0. Move it over, minus 5x is 6, divide by minus 5, same answer, right? That's okay too. Good on that? So you got to do the whole denominator and the little denominators. No denominators can be 0. Questions? Okay. So they're saying f of g. Yeah, this is tricky. Okay, so f of g is sticking all of g in. So go ahead and do that first off. Stick all of g into f. See what you get. So I'm going to put all of g into x's input slot, huh? Right? Squared plus 4. I'm going to put all of g in there. What is g? Square root of x minus 1. Good so far. Let me write this. Do not simplify for domain questions. Because I assume you're wanting to say, well, look, Mr. Aaron, can't we just simplify that? And the square just cancels the root, and this is just plain x minus 1, right? These guys just cancel. You're right. That's true. And so can't we just say then this is x plus 3 in the end? Yeah, you're right. That's true. That is the simplified version of that. But for purposes of the domain question, you really have to work with the original. Why? Because the original is the actual structure of the thing, even though we've simplified and cleaned up the look of it, it really is what it originally is, truly. And that matters because what does domain ask? Well, what are the problem areas? And what problems do we always have with square roots, with the inside of a square root? What problem is there? You can't have negatives because the square root of a negative is imaginary, right? So you got to say inside, you got to be greater than or equal to 0. Anytime we have a square root, an even root, a 2 root, inside's got to be greater than or equal to 0. So you think, yeah, but when we get it all cleaned up, there's no more root. Yeah, but there really was a root, though. It's just, yeah, they canceled, sorta. Now, I know back in your algebra days, we just said, hey, they just canceled. Really? Now you're moving more towards what's really true as you move towards calculus. Really, that root is there. Yeah, it's simplified, sorta, kinda, but really, this is f of g, really, which means really, there's a root. And really, you can't plug in some x value that would make that inside be negative. You think, yeah, but it squares it. Yeah, but if it's negative for a moment, the square root of a negative is imaginary. And you can't fix that by just squaring it. It's really imaginary. So, long story short, don't simplify for domain questions. Leave the original for domain. In a minute, they're going to ask you to simplify. So we will do this in a minute. They'll say, hey, what's the cleaned up, simplified version? And we will need to do that. But what I'm saying is if they ask you domain, which is what they're asking right now, do the original for domain. Don't simplify. All right, so looking at the original, I got a square root, grab the inside, which is just x minus 1. Say, hey, inside, you got to be greater than or equal to 0. That's simple. Move it over. X is greater than or equal to 1. That's the answer. That good? Not good? Questions I can answer? All right, so use the original for domain questions. Don't use the simplified version at all. All right, so like f of g, I'm just going to do this one quick. F of g means stick all of g into f. So that means stick all of g into f. So it's 7 parentheses plus 5, and what is g? It's x squared. Good like that. I just put all of g into f. Now, what's the domain of that? They're asking domain again. Well, it's all reals. There's no problems. Right? There's no roots. There's no denominators. So it's all reals when there's no roots and no denoms. If there's no roots and no denominators, there's no problems. It's just all reals. All 4 of these, A, B, C, and D, are going to be all reals. Because there's no, there's no roots in anybody. There's no denominators in anybody. So putting one in the other or whatever, it's not going to make any problems. Does that make sense? All reals on that. It knows everything's fine. You can plug any number you want in. There's no restriction on what numbers you're not allowed to put in. You can put anything you want in. There's no problem areas. There's no square roots. There's no denominators. There's no way to mess it up going on there. So is that good? So this is what they want at first, and then the domain is all reals. on that. Yeah. Let's do the other way though. I think it'd still be valuable. Let's do g of f. Can you do that? So just see if you can get g of f. So switch it. The domain's going to be all reals, but go ahead and just find g of f. So this time I'm putting f into g, huh? So g is whatever squared, and so you're putting all of f in there, right? Does that make sense there? So I put all of f into g. And so then you just got to FOIL that, right? So you just got to go 7x plus 5, 7x plus 5, and get 49x squared plus 35x, right? It's going to be 70 plus 25. Yeah, so just make that 70. 49x squared plus 70x plus 25. And again, the domain's all reals. There's no problem areas. Is that good on doing that? F of g, g of f, and then f of f just means put f into f. Is that confusing? Do you want to see that? F into f, maybe?
With the x that you put 7x.
Right. So f of f means all of f into f. So that means, so you're plugging into 7 blank plus 5, right? And what are you putting in the blank? 7x plus 5. There's all of f into f. And then just distribute and gather like terms. Right, boom, boom. 49x plus 35 plus 5. 49x plus 40. Good? All of f into f. Then all of g into g. Are there bad ones at the end? Anybody know? No? Kind of the same all the way?
Yeah, if you just click on the example, just kind of imitate the pattern. But then, I would like to understand why they do it like that.
G into F, yeah. Hopefully we'll have time for that. So, let's put G into F. So that means we're going to put into 9 over blank minus 7. Right, that's the format of F. We're going to plug all of G into that. What is G? 1 over X. Good so far? Just put G into F. So that means all of G went in right there into F. Like that. Good. Now, two things. We're going to have to do domain. When do you do domain? Before simplification. We also have to simplify. We can't leave this. They don't ever want you to leave fractions over fractions. So we're going to need to clean it up. But since we're doing domain first before simplification. Remember, like I wrote a minute ago? So before you simplify, do the domain. The domain must be done on the original plugin, what it first looks like. Because later you'll see it'll look different. So, okay, so what do you do on the domain? What's the domain? Any denominators cannot equal 0. Do you see that we have two denominators here? This is a denominator, and of course he cannot be 0, and the whole thing's a denominator. So 1 over x minus 7 can't be 0. Is that good? They both can't be 0. The little denominator and the whole denominator cannot be 0. How do you solve this equation? Let's multiply through. I'll do it the multiply through by the denominator way here. So multiply through by x, cancels right there. Get 1 minus 7x cannot equal 0 times x is just 0. Solving for x. Am I going too quick? So I took the whole denominator, 1 over x minus 7, not equal 0. Then I'm multiplying through by the denominator. Right? Whenever you have fractions to solve, you just multiply through by whatever's in the denominator, x. Cancels here, that's why I'm doing it, because I want to get rid of fractions, right? So 1 minus 7x, and 0 times anything is just 0. So bump the 7x over there. 1 cannot equal 7x, divide by 7. X cannot be 1/7. So x cannot be 0, and x cannot be 1/7. Those are the two no-nos. Those are the two restrictions on the domain. Now, so that's the domain. We handled the domain. Cannot be 0, cannot be 1/7. Anything else is fine. You can plug any other number you want into this f of g, this new creation of the composition, the composing together of f and g. Put anything you want in there, but don't put in 0 and don't put in 1/7. Any other number's fine. Those two will choke it, make the denominator 0. Now, we have to, we can't leave the answer like this. We have to simplify it. So how do you simplify when you have like fractions over fractions?
Work with the bottom one first.
You multiply everything by, again, same thing as other fractions. Multiply everything by the common denominator. What's the common denominator? What's the only denominator? X. So you multiply top and bottom, all the terms, top and bottom. I'm doing the same thing to the top and the bottom of the overall fraction, so that's legal. I'm not changing anything, right? As long as you do the same thing, top, bottom of fraction, you haven't changed it. You just change the way it looks. So what do we get then? F of g is going to be 9x over, these guys cancel, that's why we're doing it, because we don't want fractions under fractions. 1 minus 7x, there we go. That's better because that's just a normal fraction. It's not fractions within fractions. That's called a complex fraction. That's a mess. We like this better. And so there we go. But do you see, guys, is everybody good to there? Questions on that? Does everybody see, though, that if we had just done this right away and then tried to do domain, that we would have never seen x cannot be 0? You know what I mean? We would have just said, okay, denominator, 1 minus 7x, you can't be 0, which is exactly what we did here, and we would have got the 1/7 restriction, but we would have never seen the x can't be 0, because that was only viewable on the original. That's why domain questions must be answered from the original before cleaning up. Good? On that? So complex fractions, that's what you do with them. Maybe we should do g of f. I'm going to do g of f and then we'll move on. G of f. So try g of f. Get the domain and then simplify it. So all of g into f. Oh no, all of f into g. What am I doing? That's what I did last time. Other way. All of f into g. Like that? You don't need those parentheses, really. Is that good? To there so far? All right, it's 1 over, and then you plug in f. 1 over f, basically, right? Okay, now we're going to simplify it in a moment, but first we got to do the domain thing. What does the domain say? No denominators. How many denominators we got? Well, this is clearly a denominator. You can't be 0. And the whole thing's a denominator. Right? 9 over x minus 7 cannot be 0. Right? Remember, little denominators and big ones can't be 0. Is that good? So solve both those. This one's easy enough. X cannot be 7. But what about this one? How do you solve this guy? What do you do? There's a couple things you could do. You could cross multiply. You could put this over 1. And diagonal. Or you can just multiply both sides by x minus 7. That is the denominator. Right? You could just say, I'm just going to multiply by the denominator. Isn't that what we always do when we have fractions? Yeah. Right? That'll cancel out here. 9 cannot equal. What's 0 times anything? So 9 can't be 0. Okay, 9's not 0. There's nothing here. Nothing to see here. Move right along. Nothing to see here. Right? There's no problems there, in other words. There's no way this fraction could ever be 0. Of course, think about it for a second. How could 9 over x minus 7 ever be 0? How do you make a fraction become 0? Only by making the top 0. The bottom can't make a fraction 0. Only the top can make a fraction 0. And the top is 9. Period. He's not changing. It's not 9x. There's no variable up there. The top is just 9. This fraction will never be 0. Right? The only way to make a fraction 0 is to make the top 0. Does that make sense? That comes up in calculus. I remember teaching calculus, doing some fancy derivative stuff and getting to some point, and then solving I put it on a test. I still remember it was a few years ago, and I put something on a test, and then I was grading it later, and they were all, Mr. Harrell, we didn't know how to solve the fraction equal 0. And we're thinking, oh, you guys don't know the only way a fraction can be 0 is if the top is 0, right? That's the only way. So make sure you know that. The only way a fraction can be 0 is if the top is 0. The bottom being 0 makes it undefined. Doesn't make it 0, right? So the top, and so you can just look at that thing and go, no way. Top can't be 0. That doesn't equal 0. There's nothing here. So this is not true. So x can't be 7. That's the only domain restriction. Now, how do we clean this thing up? Same way we did the last one. Multiply by the denominator. Now, what's the denominator? X minus 7. So multiply by, right, x minus 7. Top and bottom. Do the same thing to the top and the bottom. Isn't that what we did right over here? Right? X, x, x. All the terms, top and bottom, by the denominator. So here, on the top, it becomes x minus 7. The bottom, these cancel, and it's 9. Or we could have just flipped it, huh? Same result. Remember? Fraction on the bottom, flip it. Same result. We good? All those fraction things can be problematic. I'm glad to go over those in office hours. I'm sure Roberto's glad to help. Make sure you work through this homework and understand every nook and cranny. All right. We can go there.
You took 3 minutes to decide, now you're going to take another 3.
All right. So let's do this, and I'll do it quick. Take G. And so they're just putting an X out there now, so that just means, just stick G and F. It's no particular number, right? It's not a 2 or a 3 or any particular number. So just stick all of G and F. Stick all of G and F, which means there and there. So we get whatever minus 4, this is F of G, over whatever plus 7, huh? And the whatever is x plus 5 over x minus 8. We good so far? So that's sticking all of G into F. That looks kind of painful. Let's do the denominator. They want the domain, huh? Yeah, these are long problems. They want the domain on all these things. Domain. What's the domain? All denominators cannot be 0. So that means the little bitty x minus 8, which is in 2 places, that can't be 0, so that's easy. X can't be 8. And then the whole denominator, which is x plus 5 over x minus 8 plus 7, can't be 0. Good? I'm just going to bump this over. Well, I don't know. It's probably not helpful. I keep changing my style. I'll just do it the same way I did the other ones. So I'll just multiply through by the common denominator, the only denominator, x minus 8. So I get cancels here. I get x plus 5. Let me scoot over. Plus 7x minus 8 cannot be 0, right? Because 0 times anything on the right side is just 0. Good so far? Trying to solve this little equation. I multiplied through by x minus 8. Canceled in the first spot. 7 is going to multiply through in the second spot. The right side is 0 because 0 times anything is 0. So multiply through by 7. So x plus 5 plus 7x minus 56 cannot be 0. 7x and 1x is 8x. 5 minus 56 is minus 51. And then bump that 51 to the other side. 8x cannot equal 51. Divide by 8. Boom, there we go. X cannot be 51/8. Or 8. That's the domain. Now, let's go back over here and clean up the original. Now, let's simplify. How do we simplify this big mess? What we always do, multiply through by the denominator, right? What's the denominator? X minus 8. It's the only denominator. Multiply everybody by x minus 8. Sneeze? Maybe not. So, excuse me. Okay, so multiply through by, thank you, x minus 8. Cancels there. Cancels there. That's why we do it. I want to get rid of those fractions. It does that for us. And then what do we have left? We have x plus 5. And this minus 4 is going to distribute. And it is a minus. Don't forget that minus is his baby. It's going to go with him wherever he goes. Plus 32 over x plus 5. And then the 7 distributes. Plus 7x minus 56. This thing's a mess. Clean it up. What do you got? Minus 3x plus 37 over 8x minus 51.
That's it.
That's simplified.
That's cleaned up, simplified. Is that good?
Oh boy.
I know that's messy. That kind of stuff is exactly what you need to make it through calculus. It's that kind of stuff all the time. That's it. That's what makes people pass or fail calculus. It's their ability to do all kinds of messy algebra. So that's really important. Get that down. I'm glad to help. Roberto's glad to help. Get all this. Spend time on all this. This really isn't just for nothing. This is if you're going to calculus, that's where it's about. It's all about algebra. All right. Maybe I'm wrong. Let's see. All right, surface area, hot air balloon, give them that formula. Okay, so that's surface area. 4 pi r squared. What else does it say? R's radius. If the radius is increasing with time, according to the formula. Oh, yes, this isn't bad. R is 2/3 t to the 4th. Find s of t. Yeah, once I tell you what's going on, it won't be hard at all. So good so far. They just give me those two formulas. And then now you can kind of think about how they write equations. In fact, let me write. I'm not writing it right. I usually just too casual. Let me put it like that. It's S of R, technically, and this is R. Normally, I don't bother to write all those details, but now it kind of matters. Okay, so it's S of R. Now, what does that mean? I haven't talked about it too much. That means S is a function of R, meaning it's got R on the right side, you know. And this means R is a function of T, meaning you got T in the right side. You plug in T to that function, right? R, radius, as a function of time, meaning you plug in the time, it'll tell you the radius. At 5 seconds, what's the radius? Plug in 5, you'll find out, you know. And this is surface area at any radius. Like, you tell me the radius, I'll tell you the surface area. That's what this function does. Okay, the radius is 3 right now. Okay, 3 squared times 4 pi. That'll be the surface area of this balloon. So this balloon, this hot air balloon, is blowing up, getting more and more surface area over time. The radius is getting bigger and bigger, where time is, doesn't say, is it seconds? Oh, seconds, yeah. Time is seconds. So that's how big the radius is at any time in seconds, and then that's how big the surface area is depending upon what your radius is. What they're asking me for is, what is S of t? How's that different than S of R? Meaning they want t stuff over here. They want some kind of equation thing. They want t stuff, not, where'd my pen go? Oh, here. Not R. Well, S has got R. What do you want me to do?
Plug it in.
Take all of R, plug it in. That's all it is. That's all it is. They just want you to plug it in.
17
Does that make sense?
Like similar, plug it in.
It's just to plug it in. Yeah. So let's do it. So it'll become 4 pi r squared, right? And what is the r? It is this. 2/3 t to the 4th. We good there? And then you got to clean that up. So I just stuck all of r into the r slot. And so now you see I only have t. See, that's a function of t now. That made it a well, let's clean it up first. So that'd be 4 pi square everything in there. Right? Square everything in there. 2 squared is 4, 3 squared is 9. T to the 4th, it becomes t to the 8th, doesn't it? Is that good? You got to square them all. And then what do you do with that? This is over 1, so 4 times 4 is 16 pi. 1 times 9 is 9, t to the 8th. 16 pi over 9, t to the 8th. You can put that t to the 8th on the top. You know being in the front is the same as being in the top. It's over 1. So there now is, you can find the surface area at any time. We eliminated the middle guy. The radius is eliminated. Give me a time, I'll tell you the surface area as that balloon blows up. Kind of thing you do in calculus all the time. All right, so let's. Okay, number of cars produced, certain factory, 1 day after T hours, operations given by, boom. So number of cars, let me write that down. Number of cars is 700T minus 10T squared. Okay, if the cost of producing in cars, C of N, oh, it's the same thing. See, then they're saying C of N is 40,000 plus, is that 8,000 or 80,000? 8,000 looks like, 8,000. And then they say, what's C of T? Well, to see what they want me to do? They want me to take all of this, because it's in, and plug it in for in there. So I'm going to move on to the last one. That'll just be plug it in, do the algebra, right?
You can't just plug in.
Let's see, they get volume is pi r squared h, and volume r squared cylinder. Height is 5 times radius. Height is 5r. So take that, plug it in. There we go. Those are just plugins. All right.